Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next video of classical mechanics. In this video, we are going to solve two problems of classical mechanics. Two problems of classical mechanics. Both problems have been chosen from the book Classical Mechanics by Falls and Cassidy. Not classical mechanics, analytical mechanics. Okay, its full name is written in the end of this lecture. Okay, analytical mechanics by Grant R. Fowles and George L. Cassidy. Okay, both problems have been chosen from the book Analytical Mechanics by Grant R. Fowles and George L. Cassidy. Okay, as usual, we first come to statement. Okay, find the angle between the vectors A equal to AI plus 2AJ and B equal to AI plus 2AJ plus 3AK. Note, these two vectors define a face diagonal and a body diagonal of a rectangular block of sides A, 2A and 3A. Actually, dear students, in solid state physics, we deal with face-centered crystal structure and body-centered crystal structure. Okay, what I have said that in solid state physics we deal with the terms body-centered crystal structure and face-centered crystal structure. Okay, anyhow, this is quite a separate discussion. We come to solution. Okay, dear students, vector A is equal to AI plus 2AJ. This implies that if we want to find out the magnitude of this vector, then it can be written in this form, which is sometimes also called norm or absolute value or modulus. Okay, instead of these double bars, single bar can also be used. Okay, it is just our discussion. Actually, its formula is that coordinate or coefficient of I and J and K are taken in squares and then their under root is taken. Okay, so here with I we have A and with J we have 2A. So A square plus 4A square whole under root, it becomes equal to 5A square. A square under root of A square is equal to A, so A will be written outside the under root. Okay, A into 5 under root. Now B is equal to this. So magnitude of B or absolute value of B or modulus of B will become equal to this portion A square plus 2A whole square, that is 4A square plus 3A whole square, that is 9A square. It will become equal to 14A square, and under root of A square is A, hence A will become outside the under root and hence we will get A into 14 under root. Now A dot B. A dot B, dear students, A dot B, actually A will be multiplied with A and 2A will be multiplied with 2A. Okay, remaining this will be multiplied with 0 because here K is 0. Okay, so A into A square plus 2A into 2A, that is 4A square. Okay, A square plus 4A square equal to 5A square. Okay, this is the value of dot product A dot B. Okay, let theta be the angle between A and B. Then we know that cos theta is equal to dot product of those two vectors divided by magnitude of those two vectors. Hence 5A square over A into 5 under root into A into 14 under root. Okay, here A square will be cancelled with this A square. Okay, hence we will be left with 5 over 70 under root. Okay, and from calculator we conclude that this value becomes equal to this. Okay, so when cos theta is equal to this value, so this implies that theta will be equal to cos inverse this value. Okay, and I have found the value of this, that is cos inverse this, from internet by online converter. There may be several other ways to reach this value. Okay, but anyhow, I have used the shortcut and simplest, easiest method. Okay, so theta becomes equal to cos inverse this, and this value is given in two different ways, in radians and in degree also. Okay, so here angle in radians become equal to 0.93 radians, while in degree it becomes equal to 53.3 degree. Okay, now we come towards the problem, the next problem. Okay, for what value or values of q is the vector a equal to this, perpendicular to the vector this. Okay, dear students, here the philosophy behind this problem is that dot product of two non-zero vectors is always 0. Okay, so we will find dot product of these two vectors and then put this dot product equal to 0, because these vectors are perpendicular. When we will put equal to 0, then value of q will be definitely reached. Okay, so we come towards its solution. A dot b is equal to q into q, that is q square, 3 into minus 3q minus 3q, and 1 into 2 equal to 3, 1 into 2 equal to 2. Okay, so this 2. Okay, now according to primary school mathematics, we can write this minus 3q as minus q minus 2q. Okay, okay, no difference, there is no difference between minus 3q or minus q minus 2q. Okay, in this way we can take q minus common from these two values, and hence within bracket we will get q minus 1. Minus, here we can take 2 as common, and hence inside the bracket we will get q minus 1. Okay, now we will take q minus 1 as common from these two figures or values, or this expression. So q minus 1 into q minus 2. Okay, q minus 1 dot product of a dot b becomes equal to q minus 1 into q minus 2. Now according to the philosophy of scalar product, we know that dot product or scalar product of two perpendicular vectors is always 0. Hence, if a and b are perpendicular, then a dot b must be equal to 0. That is, this implies that a dot b equal to 0. This implies that q minus 1 into q minus 2 equal to 0. This implies that either q minus 1 is equal to 0 or q minus 2 is equal to 0. This implies that either q is equal to 1 or q is equal to 2. Okay, so we have to find the values of q. So we have found those values, and this is the end of our video. Till next video, Allah Hafiz.